complete those surveys, that would be great. So session 2 is on crop nutrition and a bit of resource management as well. To open up the session, we've got Jennifer Preston from NIAB, and Jennifer is going to update us on their latest work on soil pH, liming policy and common scab. Jennifer, over to you. Cheers.
Hello everyone. Yes, my name is Jennifer Preston and I'm a research associate at NIAB CUF, and I'm just going to give you a bit of a whirlwind tour on a literature review that we've recently completed at CUF on soil pH, liming policy and common scab of potatoes in the UK. So just to give you a bit of background to the review aims, so the main point was to gather the historical background of current advice for the use of lime in potatoes, to explore the relationship between common scab, pH, lime and calcium in potatoes, and to collate experimental studies to summarise the current understanding in the area. Just to recap, I'm sure everyone's aware, the benefits of why you might think to apply lime in the rotation. The main one would be to correct for pH, which increases plant nutrient availability. Lime also has the benefit of potentially improving soil texture, increasing friability and encouraging the breakdown of organic matter, and all of these elements help to promote healthy root growth. You can also use lime to remediate in problem soils such as aluminium toxicity or salinity. There is evidence that applying lime can improve yield in the rotation, particularly in cereals and especially sugar beet, which is a crop which is sensitive to acidity. And also you can apply lime to reduce disease in certain crops such as clubroot in brassicas and cavity spot in carrots. Just to speak briefly about why there is this correlation between calcium and pH. So pH is a measure of hydrogen ion concentration in the soil, and when you apply lime, the hydrogen ions that are attached to the outside of your soil particles are replaced by calcium cations. There's differences between different soil types and different soil textures. So if you're in a soil which has high clay content or high soil organic matter, you'll have to add more calcium to affect the same pH change because there's a higher reserve of hydrogen ions, so it's more buffered against changes in pH. So looking at current advice and practice in the UK, as you might expect, a very small number of potato fields are limed immediately ahead of a potato crop, around 1%. And this really reflects current advice from AHDB and the Fertiliser Manual RB209, which says that liming immediately before potatoes should be avoided unless soil pH is very low, and this is because pH, or increasing pH, has been identified as a risk factor for increasing incidence of common scab. We looked at the history behind this advice. So studies in the late 19th and early 20th century started to make this link between lime and the incidence of common scab. Thaxter and Stays both noted that the application of calcareous material to soil resulted in severe scab and suggested that it should be discouraged. And the link between lime and increasing pH and scab is made throughout studies continuing into the 50s and into the 1970s, but there's no real attempt to separate between. It's assumed that calcium is the causative factor, and the link between calcium and pH isn't really teased out until a little bit later. So in terms of the current views, so more recent studies, which are very well summarised in the previous reviews, Lambert and Manza and Elphinstone, these reviews really started to tease out, and other studies started to tease out the differences, the differential effects between calcium and pH, and started to identify pH as the main factor in increasing scab incidence, so increasing pH. Having said that, pH is only one of a number of factors which can affect the incidence of common scab. We're all aware that soil moisture is an important factor for the incidence of common scab. So you can irrigate during the early part of the potato crop to create soil conditions which are less conducive to the scab organism. Nutrient levels rather than nutrient availability, there's some evidence that nutrient levels might have an effect on the incidence of scab. Soil temperature is an important factor, although one that is obviously much more difficult to control. The soil, the organism which causes common scab is happiest between sort of 18 to 22 degrees. So once you go outside those temperature parameters, you start to get a reduction in the population of the scab organism. And also the presence of antagonistic species in the soil can help to suppress common scab as well. So if we look very briefly just at the organism itself, who is causing the common scab problems. So everyone knows what common scab looks like, and this is the organism at the bottom there. This is a picture of Streptomyces scabiei, which is thought to be the most common scab-causing organism in the UK. There are a number of scab-causing organisms which have been found to be present in the UK, but Streptomyces scabiei is thought to be the predominant organism. It has a pH range between pH 5 and pH 7.5. The only other one I'll actually mention is Streptomyces acidoscabiei, which causes acid scab, which is pretty much the same, very similar symptoms, and has a pH range between 4 and 5.2. So given that we know the pH range of these organisms which cause scab in the UK, there is a suggestion that increasing soil pH beyond the tolerance maximum of the scab-causing organism could contribute towards effective control. So that would be pH 5.2 would be the upper tolerance level for Streptomyces acidoscabiei, and pH 7.5 for Streptomyces scabiei. So the risk of attempting to apply lime to increase your soil pH to go beyond this 7.5 pH would be that if you tried it and soil pH was not successfully raised above that level, you'd be potentially moving the pH of your soil into a risky zone. We collated some recent experimental studies which are outside of the normal academic publications to have a look to see what evidence we could find for this, the effect of pH on the scab organism. And this was mostly studies from NIAB Cuff looking at lime and some on gypsum, and studies from British Sugar using Limex. So the first study was, or the first experiment was undertaken by Cuff in 1994, and it was actually an experiment that was looking at potassium availability, the effect of soil pH on potassium availability. However, they noticed that the plots which received Builder's lime actually had, although there was a low level of scab throughout all the plots, those plots which received Builder's lime actually had a lower level of scab severity than those that didn't receive Builder's lime. And it's notable that the liming increased the pH from 6.9 in the control to 8.2. So that supports this theory that potentially if you're adding lime, as long as you're above pH 7.5, it is safe to add lime and you won't get increased scab, and in fact may find a reduction in your scab levels. The second experiment looked at this in more detail and tested 3 rates of Builder's lime. Again, a fairly low incidence of scab was found across all plots. However, there was found to be a slight directional sort of beneficial effect of Builder's lime, although you'll notice that this didn't actually increase pH out of the risk zone. It only increased it from 5.3 to 6.6. So that suggests that there may be something else going on, as well as the pH factor. Some of the factors that we mentioned earlier might be having an effect on the incidence of common scab. Potentially there might be a soil conditioning effect, so that the addition of lime is improving the soil texture and affecting the ability of the soil to hold water. So this might, as we said earlier, create a negative environment for the common scab organism. Moving on to a study from British Sugar. So I've included the website down the bottom here if you want to go and see the original report. So this was work undertaken by Richard Cogman at British Sugar. So Limex is, I'm sure many of you are aware, a byproduct of the sugar purification process, and it's used to correct soil pH. However, they received anecdotal reports that, as well as correcting soil pH, Limex had been reported that it was reducing common scab levels. So they decided to undertake replicated experimental trials and then also some strip trials to see whether they could find this effect. So they undertook experiments between 2012 and 2016 over a range of soil types, and they found that the most consistent treatment in terms of maximum marketable yield was 7.5 tonnes per hectare of Limex. And they concluded that when they were able to raise pH over 7.5, there was an action to suppress scab. So I don't know if you can see across the, this was the 4 sites from 2013. So 3 out of 4 sites, they increased the pH in comparison to the control to above 7.5. And these were the plots that experienced a reduction in the incidence of common scab. And the 4th site, which was on black fen soils, they were not able to increase the pH out of that risk zone, and there were no significant changes in incidence of scab at that site. This is just a general indication. It's not taken from the raw data. So this is the sort of general trend across all the years, and then the average at the end. So the green bars are the plots that were treated with 7.5 tonnes per hectare of Limex, and the blue is the control, and you can see there's a general trend towards a higher scab-free yield percentage in those plots which were treated with Limex compared to those that were not. So slightly moving away from lime, CUF have also undertaken experiments which looked at the relationship of gypsum to common scab. That wasn't the main aim of this experiment. This is actually an experiment looking at slow-release nitrogen, but because ammonium sulfate was being used as one of the fertilizers, they were trying to control for the effect of the sulfate. So gypsum was used as a fertilizer or as an amendment, and it was noted that soil pH in the top 30 centimetre was not affected by the rate or type of the product. So there was potentially expected to be an effect from the ammonium sulfate on the pH, but that was not seen. But it was noted that applying the same rate of sulfur as ammonium sulfate was actually less effective at reducing common scab. So there was lower severity of common scab compared to no gypsum applied. Sorry, I'm working backwards through the points on that one. And then following on from that, there was an experiment which was looking more into the calcium content of the amendments. So 3 rates of gypsum were tested along with calcium chloride, potassium sulfate, potassium chloride, and a control. And it was found that as the rate of gypsum increased, the severity of common scab reduced from 12% surface area affected down to 7%. And the severity of common scab was also reduced by the calcium chloride, but not by potassium chloride or potassium sulfate. And again, in this case, there was a change in pH, but gypsum actually reduced pH. So you're still seeing this reduction in the area affected by scab, but the pH is not being pushed out of that top 7.5 pH zone. So again, we don't really know why this is, but the suggestion that it might be the same effect as the builder's lime, so that the gypsum is actually improving the water holding capacity of the soil and providing benefits in terms of the incidence of scab through that mechanism. in summary, sorry that I've whizzed through that a bit quickly. In summary, is the current recommendation for avoiding lime ahead of potatoes correct when pH is not increased above 7.5? That's kind of a roundabout way of saying you might be, if you were looking to modify or add a little nuance to the advice that you give in terms of liming ahead of potatoes, you're probably correct when you're saying that at low in acid soils you don't want to be applying lime because you would be moving your pH into this risk zone of common scab. However, if you're able to increase the pH so that it was above 7.5, there is some evidence to suggest that that would be safe to do so. So therefore, does the advice need to be modified for high pH soils? And it would also be good as a part of this to identify which pathogenic species are found in the UK and to confirm their upper and lower limits of their pH tolerance, as this will help to improve knowledge of which pH you were targeting when you were trying to avoid your risk zone. Thank you.
Wonderful. Thank you very much, Jennifer. Great start for this session. So next up, we're going to have a double act. We've got Nicola Dunn from AHDB and Anthony Hopkins from UKIA. I will leave them to segue smoothly from one to the other, but Nicola's going to kick us off. And just a reminder that we will be having the panel session at the end, so you'll have the opportunity to question Jennifer and others then. Nicola, over to you.
Thank you. Afternoon, I'm Nicola Dunn. I'm from the AHDB Resource Management team, where I focus specifically on water as a resource. I'm going to give a brief overview before handing over to Anthony to give us a bit more of a technical perspective, but I want to cover some of the issues that we faced this year around drought and water availability. So you've all seen this map before, and we've had this a couple of times this morning already, but we can't talk about water without covering the 2018 drought situation. It's worth reflecting at this point that although most projections in the spring were looking like we were going to have favourable irrigation prospects as we go forward after that wet weather in April, the long period of little or no rain that followed and the high temperatures quickly became an issue for us that we had to focus on rapidly, and we created AHDB's Drought Hub in response, looking to provide practical information for growers that could be used immediately rather than focusing on issues around resilience. No one wants to be talking about resilience when you're in the middle of a problem. But now as we move forward, we need to think about the future issues that we might be seeing as we go forward and as the risks increase. So, I might just stay there just now. Soil moisture deficits and groundwater levels at present remain quite low, with lower than average rainfall currently being experienced across much of the country. So drought preparedness remains on our agenda as we go forward. AHDB does have some resources that can help, and we focused in 2018 on producing the Seasonal Water Management for Potatoes Guide, version 2. There's also a lot of guidance on horticultural production and through our Great Soils programme as well available. There's a lot of information from other providers though, and it's not just AHDB that provides information in this area. Hydrological information is produced jointly by the Met Office, by CEH, BGA and EA and others, and they provide monthly outlooks looking at the current status, historical and climate data to give a forward look really from the 1 to 3 month projections, giving an idea of whether or not water is going to be an issue. So this information all feeds into the Environment Agency's irrigation prospects at the beginning of the season, and we expect to see the first information coming from the EA probably in February next year. So the next couple of months are really critical for groundwater recharge, for reservoirs to refill, and depending what happens over the winter, we'll know what sort of situation we're going into for the 2019 growing season. These will provide a view on the likelihood of the restrictions that we might face, such as hands-off flow being placed on licences as we go forward. I just want to point out another tool that became available this year as well that came from Cranfield University. This helps, it's called de-risk, and it helps to give you an understanding of the water risks that are being faced. You plug in some basic information on your cropping, the location and the licence details for how much water should be available, and it should give you an idea of what headroom you would normally be looking at, and it can really just help to crystallise some of those thoughts that we've probably already got about the riskiness in some situations if we get a year like 2018, which is possible. So from a research point of view, although we don't have a standalone research programme at AHDB, sectors have funded work in the past looking at issues such as deficit irrigation or the control of common scab. But what we're trying to do now at AHDB is to look at what we can find from other research programmes that have already been funded by government and others, and to exploit information from those programmes and really translate that knowledge into something that we can use. So working with those academics on those programmes, looking at drought forecasting and improvements there, looking at impacts of drought and what information we might be able to put out in the future to help mitigate drought as it happens. So the image on the right is showing some preliminary work from the Centre for Ecology and Hydrology that looks at seasonal forecasting, and at the moment it's actually quite an uncertain science, and really you can only be quite sure of what's coming sort of 1 month down the line, but it'd be quite interesting to see how that develops as forecasting abilities improve over the years. So as we look to build drought resilience, one of the most important areas you won't be you'll be quite familiar with, I'm sure, is around abstraction licensing. So making sure there's headroom in licenses for those times of drought, or for facilitating water trading. Ask for more water if it's needed in discussion with the Environment Agency, and I would say if you're involved in that side of things, contact the Environment Agency at the earliest opportunity to discuss those. Storage of water, we've heard it before, but it's really the thing that gets businesses through those difficult years. Being able to take water when it's available at the high flows will become increasingly more important as we go forward, especially with climate projections showing that rainfall patterns are likely to change in future. We can't rely on summer rainfall. Again, licenses can be varied to take advantage of peak flows, which may occur outside of normal licence times, and my message at this point would be to speak to the Environment Agency if you want to pursue that. But finally, something that's certainly needs to be on our radar is issues around resilience and making sure we make best use of the water that is available. So how can we use new technologies to better monitor soil water status, schedule irrigations based on actual and predicted conditions, and monitor the crop response. Ensuring that efficiency of applications, making sure that every drop counts, is so important. And on that point, I'm really pleased to be able to hand over to our next speaker, who's Anthony Hopkins from Root Water, who's the chairman of the UK Irrigation Association, and Anthony's going to give us a bit more detail on efficient irrigation. Thank you.
Thank you very much, Nicola. Good afternoon, ladies and gentlemen. Unfortunately, it's perhaps not the Anthony Hopkins you all think about when you think about Anthony Hopkins. Never mind, you've got me. So, my subject today is irrigation without irritation, which is something that people always associate irrigation with a lot of irritation. Well, over the years, perhaps nearly the last 40 years, I've been involved in irrigation in one way or another. From a small boy on the farm where we had standpipe irrigation that you moved every 3 hours, to going on to the mid-70s when we got one of the first hose reels, which revolutionised irrigation and has done for a good number of years since. But now, with water becoming more of a finite resource than perhaps than it was, and there's more irrigators, I think we've got to look at ways of using water more efficiently. So without further ado, we'll start. So the first thing when you're thinking about irrigation is planning and design. So today I'll cover things like where the site is, why you have to consider the topography, why the water source is important. Have you got electricity? Because if you've got electricity, you can use electric pumping, which is quite a bit more efficient than diesel. Is it available? When you plan an irrigation system, is there room to expand the system? You might buy a system to do 50 hectares, and in 2 years' time you want to do 100 hectares or 150 hectares. Crop systems, not all crops need the same irrigation. So is the one system fits all, or do you have to change systems to do different crops? Cost, I'll cover that one right at the end, because that comes with profitability. Practicalities, the practicalities of irrigation. In the early days there was lots of different couplings, different pipes, different systems, and when I mean practicalities, you've got to standardise some things, make things modular. So if you've got different crop requirements, that system's modular so that you can swap from one crop to another and match the crop needs. Which system's the best? I don't know. But all I do know is you must apply water efficiently to get the most profit. What are the costs of the extra profit? I'll come on to that one later. How do we measure efficiency? Is it saving water? Is it saving time? Is it how you use the water? Well, all crops need water to grow. And if you think about it, if you give them too much water, they won't grow. And if you don't give them enough water, they won't grow. So you've got to be efficient. When I said before about modular systems, this is what makes systems practical, easy to use, easily adaptable to different crops, user-friendly. You don't want a system that people don't want to use, because what happens, and I've seen it many times in the past, where people buy a new system, whether it be irrigation or something else, and you can't get your men on board, you can't get the manager on board, and it ends up in the nettles. So from day one of the biggest considerations, who is going to be responsible for running the system, making things work, getting the best out of it. It's like everything in business, it's all about people. We can have all the technology, but at the end of the day, it's people that make the technology work. So, when we come to the planning, topography and water, which I mentioned earlier, it's simple physics. 10 metres in height equals 1 bar in pressure. So if we're planning an irrigation system and the water is out of a river, and where we're irrigating is 20 metres high, and we need 10 bar pressure at the top where the hose reel is, for instance, because 95% of irrigation is hose reel, you need 12 bar at that pump. So you're using 2 bar in pressure just to get the water to the machine. Water source, mains water, very expensive, but often necessary in places where there's no other water resources, particularly in ornamentals and horticultural crops, protected cropping. Then we get borehole water. Well, borehole water's good and it's clean water generally, but it depends where you are in the country, because obviously you can get salt intrusion, you can get iron in the water, and all these things are a contamination. Surface water, that can be in a reservoir, or it can be in a river, or it can be in dikes like in the fens. And securing the water with a reservoir is probably the best way to secure your irrigation water needs, because as we've seen this last year, a lot of people have run out of water, and if you've been able to store the water in reservoirs, you've had the water there to supply the crop the whole way through. Some people have run low. I can't remember 75 like I can remember 76, but many old farmers have told me this year is like 75. We ran to spring and it was wet in 75, then it stopped and it never stopped raining again while September in 76. If that is the case, then I think we all need to look at using water more efficiently, or we won't have enough to grow the crops. Water quality influences micro-irrigation, drip, sprinkler systems, so you need filtration. If you don't have the correct filtration, then the systems can fail by blockages. So, you know, that is very important. And as I said before, water availability, it's okay buying all the kit, but if you haven't got the water, the kit won't work. So, I'm going to cover the different irrigation systems to the best of my knowledge. Traditionally, as we all know, hose reels with rain guns. They came in the mid-70s and they're still with us today, and I dare say they'll be with us for a good few years to come. But things will change as resources of water deplete. Then there's hose reel and booms, not so much influenced by the wind and the weather. And as I said, when I was a boy, it was solid set sprinklers that you moved every 3 hours. Now we've come back in the last 10 or 15 years with solid set sprinklers that are set in the field. And I'll show you some pictures of those later. Drip and trickle irrigation. There's about 3 or 4 different types of drip and trickle irrigation, which I'll explain a bit later. And I'll go into the pros and cons of them all, because there is a place for all irrigation systems, but there's a cost how you use them to get the water on efficiently. So as we all know, this is the one, the rain gun. Puts between 10 and 25 or even 30 mil an hour on. 95% of the irrigation in the UK is done with a rain gun, and as we all know, we can get runoff on slopes, which can be affected by wind, but generally at the end of the season, you've got a reasonable coverage. So is it efficient? It can be efficient, but it has to be used properly. And to use it efficiently, it can work out to be very expensive. And I'll explain that a bit later. One misconception is that a hose reel, for instance, a 110 machine with a 500 metre length of pipe on, and a 110 machine with a 400 metre length of pipe on, the 500 machine is a smaller machine because of the friction loss down the pipe. It can't put the amount of water on. So it isn't always the biggest or the longest that's the best. So then we come on to the sprinklers. These can be influenced by wind also, but the advantage of this particular system and why this particular system was put in, there's a 20 metre difference in height from the bottom of the field to the top of the field. So this soil will take 5-7 mil an hour infiltration rate, and I'll mention something about that later on. These are applying 5 millimetres an hour, and the reason why we're using sprinklers in this condition is to stop the runoff. So we're stopping the water running down to the hill. At the bottom there, in years gone by with the hose reel, it's been a big puddle. These are spaced at 16 metres, 2 8-metre pipes and a sprinkler, 2 8-metre pipes and a sprinkler, and the 7 beds between the sprinklers at 1.8 metre beds, so just over 14 metres by 16 metres. You have to have the correct pressure and you have to have the correct spacing. And people say, can you fit a round peg in a square hole? Well, no, obviously you can't. But you work on the principle that you're getting a double overlap. So we're working at a distribution uniformity somewhere around about 90%, 85–90%, and a coefficient uniformity of similar. And that's done by spacing the sprinklers and having the correct sprinklers. Drip irrigation, even the dog can do it. So I'll start with drip irrigation. I'll start with this particular system. This is a 1-year tape system. So we've got the tape that's used annually and it goes for recycling at the end of the season, and we've got 1 tape down the top of each row. This particular system would be used normally for a pre-packed potato, as we've heard earlier, for reducing scab. You'll never stop scab altogether, but you will reduce it using trickle irrigation, but it has to be used properly. So this is buried, and it is putting 1.25 litres per hour per linear metre, which equates to about 1.25 millimetres per hectare per hour. The other system is with a tape, and if we're using for processing potatoes, we'll put one tape down the middle of the row, which halves the cost of the tape. And then the other system that is used very similar is called the hard hose drip irrigation, which is a 10-year a product that lasts for 10 years. One of the constraints on that product, though, is to get the economics to stack up, they have to have the emitters wider apart, 30 or 40 centimetres. And that hard hose system is put on top of the ground in between the two rows and works for supplementary water the same as a single tape on a 1.8 metre bed. In cost, over 10 years, they're all very similar. So if I can explain a little bit on how all these systems work. I'm sure most people will be familiar with hose reel irrigation, where you've either got the pipe across the end of the field and you've got your hydrant, so you pull your irrigator out, open the hydrant, comes in, you move to the next hydrant. Well, with the sprinkler system and the drip system, we have what we call a header pipe, which is pressurised. In the sprinkler system, we do 1 hectare of a block, which is about 44 sprinklers, using 50 cubic metres per hour. And there's a valve for every hectare. The valve's on an automatic timer that can be set to preset time, an hour and a half, and it will just keep going round the field while ever the header main is pressurised, there'll always be a valve open. The drip system is very similar, but we use a 4 hectare block at a time, 3.5 to 4 hectares, which is 50 cubic metres an hour, which, by the way, is roughly what a rain gun does. So all the systems are modular. When I say, you know, you can chop and change between them, 50 cubic metres an hour, that's what we like to work on. And this is the same, so we've got 4 hectares, and the valves are all sequential, and so it'll irrigate 4 hectares, 4 hectares, 4 hectares, and keep going round while ever the header main's pressurised. Perhaps I ought to mention about buried tape on the top, hard hose on the top. If you bury the drip pipe in the soil, and this is any soil, after 24 hours irrigating, you've got a 40% bigger wetting pattern than actually if you lay the drip pipe on top of the soil. And this is because you've got more contact with the soil. That it's been so this is one of the most important things for continual irrigating, the energy that you use. This is a simple formula. So water energy equals kilowatt hours, which equals flow in cubic metres per hour. So we're working at 50 cubic metres per hour. So times the pressure in metres head. So 10 metres is 1 bar. So 10 bar is 100 metres divided by 367. I've done this calculation on a 1500 metre length of pipe, 4-inch pipe and 5-inch pipe. Just what it costs to get the water 1500 metres. So in the 4-inch pipe at 50 cube an hour, we use 16.9 kilowatt hours. It doesn't sound a lot, but if you're doing a significant amount of pumping, it is a lot. And at 5-inch pipe, we're using 15 kilowatt hours per hour. And it doesn't seem a lot of difference, but actually, if you do one season, the difference in price in 4-inch pipe and 5-inch pipe is covered by the energy saving. So in years 2, 3, 4, you've got that saving every year. So theoretically, you could buy some more pipe every 2 or 3 years if you wanted to. But this is something that, you know, when you're in the heat of the irrigation season, you don't think about the energy and the diesel, but it adds up to a substantial amount. So, keeping on the energy use, these figures are in here. You can put your own figures in, and that's why I haven't put any costs. But I say a kilowatt hour average for electricity between 10 and 14 pence. Some people say it's 20, some people say it's 10. I don't know. Diesel cost is somewhere about where it is, 35, 45 pence a litre. But my main issue here, this is the cost. I've done it in acre inches. Sorry, it perhaps should have been in 25 mil per hectare, but you can do the calculation. But what I'm trying to demonstrate is running a system at 10 bar pressure. For every acre inch, we're using 68 kilowatt hours. So multiply that up by what it's costing you a kilowatt hour. That's for a rain gun. Sprinklers are running at 4 bar, so using 27 kilowatt hours. The multi-season drip, hard hose, that's running round about 4 bar, so it's using about the same. But what's quite interesting is the drip tape, that's the 1 year tape, is using 0.6, 0.8 bar pressure, and we're using 1/10 of the energy. So as energy prices go up, you know, there's a significant saving to be made, or is it a way of adopting a different system within your farm to save energy? So I think I've covered most of the things with energy and the message I want to get across there. So soil moisture monitoring. One thing that's been around for the last 20 odd years is the EnviroScan, which is TDR, time domain reflectometry. So you have a capacitance probe in the soil, and it has a small sphere of influence, and it's logging every 20 minutes, and you can get a graph of water going into the soil, so the amount of irrigation you put on, the amount of rainfall, and what the crop's using. These just give you a snapshot of what's happening in the field. There's also capacitance probes that do the same thing. Then something that doesn't measure the, it does measure the soil moisture, a tensiometer, which measures the suction tension in the soil. So it's the same as the root trying to take the water out of the soil. These are good and give you an idea of what's happening. Then the other option is a weather station where you measure the climatic conditions, and you can put the crop factor in, and you can calculate the evapotranspiration and irrigate accordingly. But actually, you can have all the technology, but there's no substitute for going to the field with the spade and getting mud on your boots and digging about and see what condition the soil's in. And if you've got that idea and you can see where it is near the probe, then you can make an educated guess, but I would never suggest not going to the field and looking round to see what the conditions are like. If you do want to know more about the soil moisture, you know, please come and see me after, because it is a minefield, really. So my message today is you've got to choose the right irrigation system. Not one irrigation system will do all, and even if you get the right irrigation system, you've got to use it to its correct capacity. Another thing while we're using the sprinklers is if you've got 5 degrees of slope, you reduce the infiltration rate on the soil by 50%. So, you know, if you're getting runoff, you're getting diffuse pollution, you're getting nutrient leaching. There's a lot of issues, and particularly in the environment today, we need to do our best to keep the public on board. One of the major things that I think we need to all concentrate better at, instead of trying to run round and put as much water on as possible, is matching the application rate of the irrigation system with the infiltration rate of the soil. Because if you don't put enough on, as I said earlier, you won't get a result. But actually, you can put too much water on. And actually, with drip irrigation, is probably one of the easiest ways of putting too much water on the soil. So it takes quite a bit of management. And what happens when you put too much water on the soil, particularly in potatoes, and we've seen it, is that the crop will stop growing for 24 hours until it gets natural drainage. And then it puts the crop in a stress situation, so it's more susceptible to blight and other diseases. The soil structure's gone, so when you come to harvest, you've got, if it's heavy soil, you've got soil going up the harvester with the potatoes, which causes damage. If you do the watering correctly, we've seen getting a crop to maturity 5 to 7 days sooner with watering correctly, and that can be any sort of watering, because you can even do watering correctly with a rain gun. If you're putting between 10 and 12 mil on at a time, but it would mean running into the field 2 or 3 times a week to put the amount of water the crop's on, and it would cost you quite a lot to do that, but it can be done. So we've got to increase the efficiency of the irrigation systems, I think, throughout the country. If we increase the efficiency, that's going to make more water available to do the crops that need irrigating. Reducing plant stress, so potentially reducing the inputs, and most of all, preserving soil structure and soil condition, because as we keep getting told, soil is getting to a situation where it's getting knocked into shape and it's not letting the nature's going out of the soil. And we need to keep the nature in the soil. And I said I'd come on to this one at the end because everybody's dying to know the costs and the numbers, I'm sure. So profit. How do you measure profit? Is it the return you get from the field, putting as little as you can in, or putting as much as you need in to get the maximum profit? I've just jotted a few numbers down here because every field is different and every irrigation system's different. But just looking at a drip irrigation system, your cost of your tape, which goes for recycling every year, is around about the £500 a hectare. The infrastructure is round about £1,600 a hectare. This is the initial cost if you're doing, and I'm spreading it over a 20 hectare block. So if I work the costs out over 5 years, you've got a cost of about £420 a hectare. That's including the tape. And then after the 5 years, you've got the £500 a hectare. So with a 40 tonne to the hectare crop, at a £50 a tonne premium, or you're going to lose £50 a tonne because you haven't got the crop that you need to sell, you're looking about 2,100. Or if you get a 20 tonne to the acre, a 20 tonne increase, that's £820 a hectare. So you've more than double paid for the cost of the drip system in the first year. And I think I'm nearly to the end of my time. So thank you for listening to me, and I'll leave you with this. A chap gave me that when I'd done a presentation in Canada, and something quite sticks with me, and I think we'll find that's quite relevant for the future. Thank you. Is that all right?
Perfect. Great, thank you very much to both Nicola and Andy there. So, and our final speaker for this session is Robin Walker from SRUC. Robin is going to talk to us about optimising the use of phosphate. There we go, Robin, over to you. Thank you. Just the green arrow.
Yeah, so when I was asked to do this talk, I gave them a presentation and I was told to please make it simple, because at the end of the day, everybody would be tired and fed up. So I've tried to keep it simple, so we'll see how I get on. Back to basics. I'm going to talk a wee bit about soil phosphorus testing, using the appropriate method, particularly in terms of the context. So as most people probably know, soil nutrient testing is a tried and tested approach to guide growers on their application rates for key crop fertiliser inputs. And the two main methods that are used in the UK to estimate available P from soils are the Olsen method, which is predominantly used in England and Wales. And then in Scotland, we tend to, sorry, I'm from Scotland, so not originally, but I've been living there for the last 20 years, so that's where the modified Morgan bit comes in. So north of the border, modified Morgan will be the typical methodology. Now there are others, but they're the two main ones. And the reason I'm kind of raising that is, which lab do you use for your soil testing? I mean, there's loads of commercial labs around there. Has this led farmers and agronomists to send soil samples to a different lab than perhaps they used to in the past? Is this perhaps due to cost, because you can get it done cheaper up the road, or you've seen an advert and you're getting a soil analysis done? But you need to be able to kind of put things into context. Okay, you're getting a number, what does that really mean? What is that number based on, and is it relevant for your particular soil? So has this led to an increased risk that the method used by the lab is less appropriate if the soil is being tested. Again, it needs to be placed into context. Is there a risk or possibility this could lead to reduced confidence in the P recommendations made? That's assuming you've even thought about it in the first place. So on this slide here, we've got the different soil indices here for the Olsen, which most people will be familiar with. And this is an equivalence in the modified Morgan's system. So you can see here, moderate in the modified Morgan system here is equivalent to index 2 in the Olsen system. So there's been this broad attempt to make a comparison between the two, but how good is it? So what I did a few years ago was actually contacted our commercial lab at SRUC to see what soil samples had been used for both, been tested using both systems. So they have provided me with data on 234 samples which have been taken from 1996 onwards. Most of these were from Scottish soils, admittedly, but just to do a comparison. And there's other people in literature who have done this as well in the past. So the P concentrations of these soil samples were compared using the two methods, and there were a few absolute outliers which are removed completely. So we ended up with 221 samples. So what did that actually look like for this comparison from the previous table? Well, it looked like this. These kind of blue squares are the kind of equivalent soil indices. So we're going up the left-hand side here, we've got 0, index 1, then you go 2, 3, 4, etc. for the Olsen. And along the bottom line here, we've got the modified Morgan. So ideally, if they were matching, all the dots would be in these blue boxes, and quite clearly they're not. There's a general agreement at the lower classes, but when you start kind of move on to the higher classes, Olsen tended to overestimate quite significantly in a lot of places on these particular soils. Now, typically, Scottish agricultural soils will have a slightly higher pH and a slightly higher organic matter than many English soils, but not always. There are certain areas, for example, on the Maca or some of the coastal areas where you maybe have a slightly more calcareous soil and perhaps a little bit of lower organic matter. And typically in England, there's also going to be other situations where it's the other way around. So, really quite important that you kind of choose the appropriate soil analysis for your soils. In terms of GPS sampling, obviously you can do that. So soil analysis for phosphorus can vary considerably. And as we saw in the previous slide, quite considerably, particularly at the higher p-values, you get a big spread. Or if there's different soil types in the field as well. So you might have a very large field with several different soil types across it. So one average soil test is really going to kind of mask that variation. So using your GPS sampling, you can help overcome this if you can identify areas where you've got these different types. And again, using the correct soil analysis to interpret that. And if you use that information wisely, you can maybe use things like variable spreading and this type of thing to try and get a more even spread across the field and hopefully more even production. So takeaway messages from that part of the section. These results certainly highlight the potential to either significantly over or under fertiliser crops based on the phosphorus analysis results. Obviously, as I pointed out, the method used and the soil properties are going to have a large part in determining which this may occur and how far one way or the other that might take place. And as you phosphorus fertiliser recommendation systems are based on soil phosphorus analysis, it's really important, I keep emphasising this, to make sure that you're using the appropriate test for your particular soils. If not, there's a fair risk that you're going to end up with environmental issues in terms of environmental loss, whether it's from runoff or erosion, this kind of thing, and also additional cost. Why would you put more on due to excessive phosphorus purchases, so you're costing more, or you may end up with a yield reduction because of lack of phosphorus deficiency. So going on to phosphorus, fertiliser recommendation systems, I'll start off very broadly and then kind of move on to some change which have been taking place more recently in Scotland, to be a bit more pointed. So you've got your soil results, and you're happy that you've chosen the right one for your particular crop, in this case a potato crop. You use a tried and tested fertiliser recommendation system, so with RB209, these are Scottish technical notes here which do a similar kind of thing, and use things like Planet and this sort of thing. So you've got all of these at hand, and you can use the results that you've got from your soil tests. So pretty much targeting, this is equivalent to a higher end of index 2, I guess, for your phosphorus. And in Scotland, I was looking at the analysis results that came back. There were less than 20% of the soils which were actually in the ideal range, this kind of high moderate or kind of high index 2. So really, all the other 80-odd% of the potato crops were in ideally the wrong kind of level of phosphorus, wrong index for the phosphorus for growing. So obviously need to have modifications there. As I said, there's been some recent developments in terms of phosphorus recommendations in Scotland, and that's linked to this thing called the P-sorption capacity. So basically, how strongly does a particular soil series hold on to phosphorus? So an index 1 is, it doesn't hold on to the phosphorus very strongly, and that's these green areas on the map. So this was done using GPS mapping and overlaying soil series onto these, and there's indications from some people far cleverer than I am who can kind of put these into a context and come up with these kind of figures about the risk assessment. So the green ones are very low phosphorus sorption capacities, so phosphorus is relatively available that you're adding. The yellow ones are somewhere in the middle, and the red ones are really strongly absorbing, so they hold on to that phosphorus. And this table here, this is kind of the core one that we're aiming for in terms of potatoes, is what we're aiming for, and it's adjustment figures based on this sorption capacity about adjusting the kind of the standard fertiliser recommendation based on the soil type. So the top row here is the less strongly binding phosphorus, and one at the bottom here is a very strongly. So this is the red areas, yellow areas, and green areas. So it's kind of focusing on a bit more targeted rather than a one-size-fits-all. So phosphate increases the rate of early development of the crop. In potatoes, obviously improving rate of horn growth, tuber initiation, and early bulking. Except for cases of extreme deficiency, fertiliser P does not necessarily increase the growth rate of the horn persistence later in the season. P also increases tuber number more than tuber yield. So again, in terms of seed crop, that's why you tend to have a lot more phosphorus put on the seed crop. There's some justification for higher rates of fertiliser P on seed crops, but high rates of P should not necessarily be regarded as the main means of attaining a high tuber number. So again, these are the kind of things that are in the recommendations. So takeaway messages, soils with a high phosphorus sorption capacity, in Scotland the PSC 3 version that I mentioned about, there would be similar information around for England, but it's less available, but I guess that could be developed. So if you've got a higher phosphorus sorption capacity, you're trying to maintain that or above. I mean, ideally you wouldn't maintain it above that, but it's possible your soils are that. Above the target index, this kind of moderate index, you'll have a greater environmental risk. Main reason, because of this, they'll contain higher levels of absorbed P from fertilising because you're tending to put more fertiliser onto those soils. So that if you do lose some of that soil, there's more chance you'll end up with a loss. So maintaining your soils at optimum P levels is only really justified if the land is actively managed for maximum yields. Otherwise, you're going to kind of build up levels. And I suppose one of the key things here, it requires good soil management across a range of things, such We mentioned pH was mentioned in one of the previous talks. It's important. Nutrient planning, adequate drainage status and good rotation, things like maintaining soil structure, this sort of thing. So there's a few practical approaches, whether it's through products or methods. It's just a kind of a broad range of some of these things. So typical range of phosphorus fertilizers here. So you've got the ammonium phosphates, the DAPs and the MAPs, and the superphosphates, which are readily available water-soluble form. And then we've got other things like rock phosphate and other types which are less soluble. And here's just a table with an indication of the phosphorus phosphate values on them, and also obviously these have got some nitrogen in them as well. That's fairly standard. So there are a range of approaches which you may think about to try and maximise what you're doing in terms of your fertiliser. So there are these things called cation complexing ligands, which is basically a fancy name for something that will kind of knock phosphorus off a soil particle and allow that phosphorus to become available. And there is a little bit of evidence to suggest that in some instances they can work, either releasing P from the soil that's already in the soil, or increasing the efficiency of added fertiliser. Whether it's an economically viable process, I'm not sure, but there's certainly investigations going on. And this paper here by Hopkins did a thing called a meta-analysis, where they looked at data from over 500 trials that were using these types of products, and under certain circumstances, when using reduced phosphorus rates under conditions of low soil test phosphorus, and when the soil pH is either extremely acidic or alkaline, it did seem to kind of have some benefits. The other thing I'm just going to talk about is placement. So again, it's used for a number of crops, potatoes being one of them. So placing a fertiliser with a seed, or just below the seed, or adjacent to the seed, can increase early season root growth and development, enhance crop yield as well, and phosphorus uptake, particularly in these low P status soils. Benefits of placement are expected to be greater if the phosphorus sorption capacity is high. So again, some of these soils, the red ones on the map that I showed earlier, if it's very strongly binding that phosphorus, then if your placement can be beneficial there. This is an example from a trial that we ran through this project called Target P, which AHDB were involved in. This happens to be using struvite, which is basically extracted from wastewater, so it's a recycled form. This 40 kilos is elemental P, so that's around about 90 kilos of P2O5, and this one is broadcast, and this is the equivalent rate placed, and you can see the difference at this stage in the crop. There was a definite boost there. But just the fact that this is struvite, it's not the end of the world, because the other treatments that were used basically showed similar kind of rates, and there's data to back that up from elsewhere. Another thing you might consider is foliar P, or liquid P, and these can be beneficial in certain circumstances, particularly on things like seed potatoes, where uptake of soil P is restricted, or could be restricted. And foliar or liquid applied phosphorus may increase tuber numbers, so particularly in things like drier years or non-irrigated crops, this kind of thing, there could be benefits there. And timing would be quite important to make the most of these. So going back to the Target P project that I mentioned a while ago, this was a trial that we did in Aberdeenshire, although ADAS were involved in a couple of other trials in England. But in terms of the trial that we had up in Aberdeenshire, is a seed potato crop on inch soil, so it's a very strongly binding, phosphorus binding soil. Going back to my original kind of section, the farmer had he used Olsen for his soil test, so again in Scotland that would be less unusual than it was, but certainly traditionally would be quite unusual, and he was coming up with this, so sort of towards a moderate index. And we got the soil tested using the modified Morgan, which would be more traditional to use in Scotland, and it came out in the quite low category. Maris Peer was the variety. The phosphorus treatments were applied by our staff, and there were 16 treatments in total, based around these rates here. And again, this is elemental P. So we had a response curve, or the idea was to get a response curve from 0P, 40 kilograms of P, which is about equivalent to 90 something kilos of P2O5, 80 kilos, which is about equivalent to about 180 kilos P2O5, and 160. So that's a massive amount. So it's like 380 kilos or something ridiculous. So we've got this big response curve going on. And then we also had some foliar treatments as well. Materials, triple superphosphate was the core one that we used. And we also used that with a veil, which was one of these cation binding agents. Struvite, and then we had the foliar P. And then we had two application methods. We had incorporated, broadcast and incorporated, or placed. And then there was the foliar element going on as well. So some basic data. So this is the one that was really, really high. So this was 370 odd kilos of P2O5. And the control here had 0. And we had our two kind of standard triple superphosphates at 80 or 40. And then we had the various treatments in between. So if I kind of block those off here, these are all the placed treatments. And they were coming out generally higher. So this one is the triple superphosphate placed versus the one that was just broadcast incorporated. This is the triple superphosphate with a veil, which was the cation one, equivalent to that. And this was the struvite, equivalent to the struvite that was just placed. So again, the placement was definitely having an impact. These ones that I've just opened up here, so again, this is a kind of the standard treatment here, and this was using the foliar P, which was at tuber initiation. So again, you can see there's a slight increase. It was significantly so, by a few tons per hectare using the foliar. So again, that did show benefits in this instance. Okay, this is another trial we did using struvite. And you might think, well, why does it keep going on about struvite? Well, there's concerns about peak phosphorus. You know, there's a finite supply of phosphorus. It's being mined in places that aren't necessarily politically stable, so there's risks there. And it's also linked to major issues in water quality, water treatment. So I think somebody once said there's no P in urine. Well, actually there is, and this is basically it. And it's one approach to trying to improve the sustainability and recycle back some of the phosphorus being lost through the system back into agricultural use. But this slide here is basically just showing wasn't struvite on its own. It was in a mix blended with different amounts of triple superphosphate. So there was a control here that had no phosphorus applied, and this was 100% of triple superphosphate, and these are different ratios. We have a 15 and 85% struvite to triple superphosphate, 25 to 75%, etc., etc. So in terms of blending, you could get some benefits. So in summary, across the whole of the presentation, really try and use the most appropriate soil phosphorus test for your soils. Don't just go with the bog standards. Try and work out why you need to use a particular soil test and that it is appropriate for your soil. Again, use tried and tested fertilizer recommendation systems linked to your soil tests. If you can get the information, I say it's relatively easy in Scotland because it's there, but a knowledge of your P sorption capacity can be useful because that can help you kind of tweak your fertilizer applications. GPS sampling and variable rate application can help in terms of evening out a field, which can maybe help with more even maturity and this kind of thing. banding or placement of phosphorus fertiliser can be beneficial, particularly if you're using either lower rates of phosphorus fertiliser. I don't know if you maybe forgot to mention it when we showed the banding rates, the 40 and the 80. There was actually very little difference in terms of the yield, even though it was twice as much phosphorus being applied in some of them. So you might be able to get away with using slightly less fertiliser and still get the same yield. Using appropriate phosphorus fertilisers or blended approaches for particular aims could be beneficial. And generally speaking, if you're using your fertiliser inefficiently, there's risk of environmental issues such as nutrient loss in the environment or additional costs, whether that's through to excessive phosphorus purchases and application or yield loss due to phosphorus deficiency. And all of this is going to be aided by good rotation and general soil management as a kind of whole integrated kind of approach. And this is, these are the kind of clever people that were doing some of the phosphorus sorption capacity side of things. And the target P project was a DEFRA Sustainable Link Programme. And the crystal green, or the struvite, was supplied by these people as well. So, and they were involved in the target P as well. So, thank you.
Great, thank you very much, Robin. Great way of wrapping up that session. We'll move on to the panel discussion. So if I can ask Jennifer, Nicola and Anthony to join Robin up on the panel, please. Great, all settled, comfy. Excellent, good, don't fall asleep. Okay, so we'll take questions from the floor, but Slido is there as well if you want to use it. Don't let Eric hog all the first questions, so do take the opportunity to use Slido. But initially, any questions from the floor? Hand in the air, roving mic will come to you. Anyone going to be the first one to put their hand up? Should we go straight to Slido? Oh, no, thank you, at the front middle there. Sorry, just wait for a microphone.
Hello. It's a question about the calcium content that you were using on the soil earlier on. You said when you used calcium chloride compared to lime, you had the same kind of response. So do you think it's more to do with the actual calcium content that's actually going into the tubers, or effect on the soil?
I know I'm not supposed to say this, but I know Mark Stallam is out here somewhere, who actually. He's hiding at the back there, who actually was responsible for these experiments, so he will know about it in more detail than me, I'm afraid. Oh, he's on got a microphone as well. There we go. Sorry, Mark.
I wish I'd never come now. No.
Sorry.
And I will pass it on because it's actually not my work. It was Mark Allison's work, but I was intimately involved in it because of our interest in scab. And Jennifer's quite rightly broken down the three components of scab control related to the whole subject area of liming, which is soil amendment can change soil properties, and that may well affect soil water holding capacity and the sort of edaphic zone around the tubers. That's one thing. Jennifer's intimated that. The other one is the pH effect, and I think she sort of put some points together on that. And the other one is calcium per se, taken up by tubers and acting, you know, as a course of preventing scab. Now, that's also in the literature, but I think John Elphiston's work, which I was part of as a group, really said it's more of a pH effect. So we were trying to unravel a lot of things, and as Jennifer said, it started off with a test of ammonium sulfate as a slow-release nitrogen fertilizer, and it developed into a control of common scab through using gypsum and other calcium products. So quite rightly, we had to factor out a lot of things. When you add calcium from one source, if you add it from another source like calcium chloride, do you get the same effects? And no, we didn't. We generally got the effects of gypsum alone. And so that's still perplexing us. So if other people have got any ideas, our view is it's a bit like the reclamation of the Thanet marshes years ago when seawater flooded and the wrong product was used, and it took gypsum to uncover, all that damage or recover the damage. And so we think it's happening that way, but we don't have any scientific evidence for the process of gypsum. But it's not a pH-related effect.
Okay, thank you very much, Mark. Sorry you couldn't hide in the back corner.
Sorry.
I suspect we might be back to you at some stage. Any other questions from the floor? Yes, thank you. At the front middle. Just wait for the mic to come over.
Thank you. In my farming life, I'm yet to meet anybody who says, I love irrigating. It can be one of the most frustrating things. And if you've lived the dream this year in laying pipes out in 30 degrees of heat, can starting irrigating a crop and then getting a 3-week EA irrigation ban, i.e. then stopping for 3 weeks, is it worth restarting? Can it be a detriment to the crop?
You should be on,
Yeah. You've got to look at the crop, and in normal circumstances, if it wasn't this year, after 3 years non-irrigation, the crop would suffer. But if it's not dead, the crop would come back again. But it depends how far and what soil type you're on, really. I mean, if you're on a heavier soil, then there's more chance of it withstanding 3 weeks without rain. Another thing is, if you're irrigating early on, and I think this is something where some work needs to be done with the AHDB and seeing when we need to start irrigating so we can use the water efficiently over the whole season.
Okay, thank you very much. Any more questions from the floor? Okay, can we... Oh, sorry, Eric, go on then, front middle. You've got to wait for the mic to come across.
A question for Robin, please. Eric Anderson, Scottish Agronomy. Robin, can you clarify for us, I think it was the third last slide you presented, whether struvite or avail was statistically higher yielding than the 40 kilograms of placed TSP, and as a supplementary to that, which product would you recommend, therefore, to potato growers?
I honestly can't remember whether it was significantly different, but it was certainly equivalent. I'd have to go back to the slide.
Do you want to flip back?
Yeah, that one. So, where's the stru? What was the other one you wanted?
No, that's the slide I was referring to.
Yeah, so this is the struvite.
40 kilograms placed.
Yeah.
Is that any different statistically to the avail treatment or to the struvite treatment?
Doesn't look like it, looking at the error bars actually.
And which treatment are you going to
Well,
recommend?
the cheaper one at that point will be the triple superphosphate on its own.
Okay, thank you.
Thank you very much. Right, any more from the floor? No? Okay, can we flip across to Slido? See what we've got coming up. Right, here we go. Jennifer, I think the first one's for you. Can you clarify what the correct equation for H ions and calcium carbonate is in the soil? Is it not driven by calcium, otherwise gypsum would increase pH?
That's an easy one in that, no, I can't clarify that. I'm afraid I can't claim to be a soil scientist. So I would say anyone who has any questions that relate to my talk, I'm very happy to receive them over email and get back to you.
Okay.
I'm afraid that is beyond my knowledge.
Right, thanks. Thank you, Jennifer. Anyone else from the panel or the floor want to take a stab at that one? Deathly silence. Okay, all right, we'll move on. Right, sorry, moving around. So only 10 to 14% of fresh pea is taken up by crop in year of application. Is feeding the crop the correct pea strategy in future, Robin?
That was certainly the target P ethos, and that's what was being suggested as being the way to go. So using more limited, well, the idea was that you could use index 1 and you could feed the crop from that. And that's why we're utilising these different approaches to try and kind of allow that to happen. Whether we're there yet or not, I don't know.
Okay. Let's mix the subjects up a bit. Anthony, is the scope to irrigate from imagery looking at biomass and NDVI to apply vary rate for greater efficiency?
Yes, there is. I tried to apply for some money to do some research on this using an infrared camera and using drones to fly over and getting the imagery, but we were turned down. But there is some work being done in Scotland on this. So yes, there is something coming in the future. One thing that I saw several years ago with the end sensor is picking up a crop starting to senesce 10 days before you could actually visually see it. So I'm sure there is a lot of work to be done on this, and it is possible to do something to schedule irrigation looking at the biomass of the crop.
Okay, thank you. Robin, do you want to pick up that one at the top there? That's talking about variability in crop yield due to extractable P and K.
Well, yes. I mean, I think that's the slide I showed with the big scatter of dots showed that there was actually quite a lot of variability going on based on your soil test. So trying to, I mean, that figure there, I don't know where it came from, 30% of variability. But again, if you're measuring a soil with using an inappropriate test, that's going to kind of highlight the variability even further. So, yeah.
Yes. Okay, fine. Right, it's a good question. It keeps coming to the top. I'm not convinced we might have the answer in the room, but we'll go for it anyway. Eric, what happens to carbon dioxide released from soil as a result of elevating pH above 7? Do we need to have a broader view? Jennifer, is that one you want to pick up at a later stage?
Yes, it's a really good question, and it's not something that we really covered in the review, but it would be something that would be certainly interesting to look into.
And Eric keeps going there, thank you. Soil sampling, any commentary there about inconsistencies because of the size of the sample? Anyone want to pick that one up? Any views? Robin, any views on soil sampling?
You're measuring, you know, a thimble-sized soil and extrapolating it out. So yeah, it's it's not without its issues, but that's what currently is used.
Robin, the one at the bottom there, currently available irrigation scheduling support systems, which is best?
I'm not sure I could answer the one
sorry,
about irrigation
Anthony,
systems.
sorry, I meant Anthony. I was looking at Anthony and said Robin. Sorry, Anthony.
Which is the best? The best one is the one that suits the grower, and it's all about people. In my view, the spade and the boots and in the field is the best, probably used with ET, because the soil moisture pros are perhaps a bit too site-specific.
Okay, thank you very much. Just chip in if there's anything from the floor, but I'll keep going through Slido for a bit longer. Similar sort of question around soil analysis. If we're placing a lot of faith in the accuracy of the soil analysis, are we therefore sort of making rather implied decisions about the precision of recommendations for P and K? Robin?
Well, yeah, you are. We're implying that's true.
Yeah. Okay. Okay. Eric's got a good question. Reith in 69 stated the practical basis for adjusting fert dressing can only be judged from relationship to crop performance. Is that analysis useful? At the top there.
Well, yeah, I mean, obviously the crop performance is the key thing, and your soil analysis is secondary almost to the performance of the crop. So if your soil analysis says yes, it's high or low, and the crop performance, basically it's a bioindicator. So you've got a soil analysis, and the crop's going to do what it's going to do based on what's in the soil and what's available to it. So it's only an estimate. It's not an actual specific value from the soil test.
Just a follow-up question for you then, Robin. Was there a measurable difference in tuber number as a result of banding P?
There were, and that was one of the slides I took out, and I can't remember what it was.
But
Sorry.
There was a variation.
Yeah.
Can we pick that up afterwards, maybe?
Yeah.
Yeah, okay. Jennifer, would you not run the risk of locking up soil nutrients if you increase soil pH to 7.5 or above?
Oh, sorry.
Sorry, at the top there.
Again, I would have to say I'm afraid that is beyond my knowledge.
Okay.
Sorry.
No, that's fine. Can you comment on the availability of P from materials such as fibrofos? Anyone done anything of fibrofos? Robin, no? Okay. Just picking up which questions come up next. So if I lime to raise pH and reduce scab, will I make P less available and reduce the number of tubers?
I'm not able to comment in terms of making P less available, although I think that was mentioned in the literature, but it's not something we're particularly focused on. In terms of reducing the number of tubers, I think there are laboratory studies that suggest that there might be some impact on tuber number, but I don't think the evidence is there to say that categorically, and it certainly isn't there in terms of field trials that I'm aware of. So whether there is that result that was obtained in the laboratory would be translated into field situation, I don't know. As far as I'm aware, I don't think the information is there to make that, but it might just be that I'm not aware of it.
Okay, thank you. Anthony, third question down. Did we need the capacity to irrigate every 1 to 2 days in 2018, or would a frequency of 5 be sufficient? And does the answer depend on available kit?
The first thing is it would be depend on your soil type. Secondly, it would depend at what crop stage you were at. Then it would depend on what market you're doing. And if you can put enough water into your soil every 5 days for it to last, and you've got the reservoir filled up in the soil, then you can do it in 5 days. But if you're going for scab control, you'd need the kit to do it every 1 or 2 days. And I believe even in the hottest weather, there was a lot of water put on, and I don't believe the crop was using all the water. Perhaps Mark can answer this one better than me. But having enough kit to do it every 2 or 3 days, there's really only 2 ways you can do that at the moment, unless you spend a lot of money on hose reels, and that's either with drip or sprinklers.
Okay. Mark, did you want to come back at all on that point?
Well, I thought the purpose was to ask the question, not be asked it back. But no, Anthony's put all the right points there. It depends on the reservoir in the soil, it depends on whether you've got the water, and it depends on what stage of the season you are. But what I perhaps could allude to is that if you got to full crop cover on a medium soil, I'm still sceptical, and I want Anthony's view on this really, is do we need to go any faster than 5-day intervals with 5 millimetres per day? I've sort of seen a lot of crops this year do extremely well on that proposal, where they've been slipping to 7 and 8 days, which is more like a normal season. Yield has suffered. But going any more frequently, I'm not convinced. And I'd just like Anthony's view on that.
Yeah, I'll answer the question now. I know what the exact question is. And the answer to the question is, no, you don't need to go every 2 or 3 days. But my message is, when you're putting the water on the crop, don't put any more than 5 mil an hour on. So if you want to put 15 mil onto a crop, irrigate it for 3 hours. And then you could go every 5 or 7 days. Does that answer the question?
Great, thank you. Robin, do you want to try and pick up that top one? If concentration of P achieved through placement was applied in a broadcast, would you get the same yield increase?
I don't know whether that means concentration of P across the whole of the soil, or whether it means, certainly the results that we got in terms of the equivalent rate of phosphorus in the placed was better than if the same amount was applied as a broadcast and then incorporated. But if that wasn't what was meant, and it was the same physical concentration in the soil across the whole piece, I don't know, because we didn't measure it.
No, sure, okay. And what about the top one again? Is recovery of P and K more important than actual indices, soil health, organic manures, etc.?
Recovery of P and K, is that by the plant? I don't know what that means. Is that?
Whoever asked the question, do you want to clarify what you were getting at? Do you want to own up to the question? Clearly not. Okay, all right, we'll park that one. Jennifer or Mark, just a little bit about why nutrient levels increase scab. Jennifer, do you want to...
Again, this wasn't a particularly large part of the review, but we did revisit that more recently as... So I think I've given you the wrong impression there. I didn't mean to say that nutrient levels necessarily increase scab. So there are different, my understanding is that there are different effects depending on which nutrient you're talking about. So nitrogen, for example, might have an indirect effect to suppress scab in that it can acidify the soil, and therefore you would be reducing soil pH and potentially suppressing scab. And then other nutrient levels, I think there are differences between different field conditions. So there are differential effects in different circumstances, and there is no sort of hard and fast rule that I'm aware of. However, in terms of nutrients such as like manganese and P and K, sorry, the ratio of calcium to K. And I was going to say something else then. Sorry, it's gone. Oh yes, I was just going to say the overall view that I took away from the literature, that part of the literature review, was that if you have a healthy plant, if you have a potato plant that is well, has a good supply of nutrients, it's going to be more able to defend itself against incidents of common scab. So you would expect scab levels to be lower in plants that are generally more healthy. But that's my understanding. That might not be quite right.
All right, thank you, Jennifer. Right, very topical question to finish us off, I think. Anthony, with the increase of secondary growth this year, do you think irrigation at shorter intervals could have helped prevent by alleviating stress?
I think when you get over 24 degrees, you can probably take the crop to 26 degrees before it shuts down. But when it gets to when the heat gets there, the crop will shut down anyway. It goes into the dormancy. So irrigation will probably take it a couple of degrees above and keep it growing, but it won't stop it altogether growing.
Okay, right, guys, thank you very much for your questions. I know we haven't covered them all, but as I say, we'll try and pick those up after the event. We'll wrap the panel session up there and just say a big thank you very much to the panel. Thank you very much. Take your seats. That would be good. Right, okay, that brings the first two sessions to a close. I hope you've enjoyed day one and its focus on potatoes. For those of you staying overnight tonight, tomorrow's sessions will focus on cereals and oilseeds. I'd like to give a final thank you to all of the speakers, facilitators and general organisers today, all of you for your questions and engagement. So if we can just do a final round of applause, please. I've just got a few final announcements while I've got your attention before you go. So really just to make the point that we have specialist knowledge exchange managers throughout the UK covering both cereals, oilseeds and potatoes. They're not very big on the screen, apologies for that, but they are in your delegate packs. Please make every effort to make contact with your local KEM. They will also be trying to make every effort to make contact with you, but it is very much a two-way thing. So please use them as your point of contact and your entry into AHDB. On a similar vein, we now have 22 arable monitor farms, 7 strategic farms, meeting about 5 times a year on average. That's a lot of local meetings across the whole of the UK that you can join in with, and we'd very much like to see you there if you haven't come along yet. To give you an idea, even the strategic potato farms alone are getting up to 1,000 people attending in a 12-month period. So if you haven't been able to get along yet, please do so. If you're not sure about where the details are, either have a look on the website or, as I said earlier, contact your local KEM for the area. As I say, all of this information is in your packs. We also have a wide range of other technical events, so have a look on the website for the full programme of events, how to apply to be a monitor or strategic farm, whether it's yourself or clients or contacts, colleagues, whoever it might be. We are recruiting at the moment for new monitor farms and new strategic farms, so please put people forward. Closing date for that is around Christmas time. Have a look for our online tools and resources, in particular our benchmarking tool, FarmBench. look out for details. We've got a storage roadshow happening throughout the country, Jan, Feb, March in the new year. So those of you who attended the storage workshop today, if that sort of whetted your appetite, please make every effort to go along to your local event. Of particular interest for those of you in the room, local agronomy events. So we effectively take this event on a tour around the country. Obviously the topics are altered to suit local requirements, and we have local people engaged in it to give it very much a local flavour, but the dates and locations are up there on the screen. Again, they're in your pack, so it'd be lovely to see you there at those. Finally, believe it or not, we have got dates for this conference next year. So 3rd and 4th of December 2019, please take the opportunity to lock those dates into your diary. We have checked at the moment, they don't clash with anything else, so if anyone else subsequently clashes, it's their fault, not ours. And then just a few bits and pieces of admin really, and then we're finished off. So for those of you who are leaving us now, I hope you've enjoyed it. I hope you have a safe journey home. Please complete your feedback form, which is that one in your packs, and your keeping in touch form. I won't bore you with GDPR regulations, but it's meant that we've had to almost start from scratch with our database, so don't assume we've got your contact details. So if you're leaving today, leave us with your feedback on the event, that's really important, and equally leave us with your keeping in touch details, that's just as important, and make sure you include your your preferred point of communication, because that then allows us to actually contact you, and please hand in your name badges at the registration desk when you leave. For those of you who are staying with us, the cash bar at the hotel will open at about 6:30, so look forward to seeing you there. Dinner will be served about 7:30. The venue address is in your packs, but basically you're going east 1 junction on the A14 back to the hotel. Don't wait here expecting to be fed, because you'll be sorely disappointed and you'll be on your own. So I hope you have a good journey home, or I hope you have a good night tonight. Either way, I hope to see you soon. Thank you very much indeed. Thank you.